All right, I think it's 6:05. We have around 22 people. This session is also being recorded, so if people are joining later, it will be shared with you for your reference. Those of you who have not yet registered for the maths qualifier exam, you're requested to do so. The the next date is the last date for this cohort. The exam will be on, I think it is 8th. Let me just check. Yes, it's 8th February. So you have two slots there. So please register. And it's a simple exam, and I think Professor Y.V.K will explain all the basic concepts to you. And if you have any other friends or acquaintances who also need to take the maths test, you can encourage them to do the same. All right, Professor Y.V.K, over to you, sir.
Oh, thank you. Thank you, Ajit ji. Thank you. So, welcome all. Welcome to the discussion. Just we'll try to have a brief understanding related to basic mathematics. Which is very easy actually. It is like a recap of what we studied at the school level. So, so these are the topics which you need to have a basic understanding, like complex numbers, quadratic equations. Right? So now we have a wrap up of some of these concepts, and also we'll see if you had any particular queries, we'll discuss.
Professor Y.V.K, are you on a wireless network by any chance?
Yeah. So let us take complex numbers, right? So we know the basic understanding of complex numbers, where the pardon?
Sorry, I think the internet connectivity was a little poor. If you're on a wireless, you can see if you can get on a better wireless or a LAN connection. There seemed to
It
be a
is
little bit of
actually LAN, it's from office only.
okay. Okay, now it is better. Initially, it was a little jerky.
Yeah, it is from August
Okay.
only, and we have to check.
Okay. 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 Now it's good. Now it's good.
So where the simple number system, where we'll try to understand the basic complex number. Right? Z equal to x plus ay, where x is said to be real part and y is a imaginary part, right? What we call as. So what are the things we need to, the basic understanding related to complex numbers, what we need to have is, so whenever we have this I is nothing but square root of -1. So where I square equal to -1. So whenever we had where x and y are some, if we take, we can replace x and y by, whenever we talk about a complex numbers, then we'll have a associate which is called as conjugate. Right? So when that means whenever, suppose if we take 2 plus 3i, right? Now from this we can understand, so this 2 is nothing but real part, and these 3 comes with I, therefore it is imaginary part. So wherever this a plus iv or x plus iv is there, then it will have a companion, you can say, simple sense, which is 2 minus 3i, which is called as conjugate. That means wherever we find a real number and complex number with plus or minus, then we can write its conjugate. Right? That is one understanding. So most of the times, whenever it is a very easy and important for us to identify for a given expression, what is the real part and what is the complex part. The other one is the absolute value of the complex number. The very simple, whenever a complex number is given, the square root of the real part square and imaginary part square, the sum of both these, is nothing but absolute value of a complex number, and generally we denote it by mod of z. Now it is very easy to deal with these things. Right? Suppose here to have a summary of the discussion what we had. Now, if you see here, find the real part of this expression. Now, what we understand is whenever we put it in the form of a plus ib, then we can say what is the real part and what is the imaginary part. But in this case, it is a combination of, that is product of two complex numbers. The value is simple. Now we need to put it in the format. So how to put it? Simple multiplication. It is a simple multiplication, not complex as well. General multiplication, whatever we do, right? Same way, 2 into 4, right? And 2 into minus 2i. 3i into 4, right? And 3i into minus 2i. The regular simple multiplication only. Then plus 12y and I into I square is there, plus into minus minus 1. Now, as in this is the basic understanding, I square is nothing but minus 1. I equal to square root minus 1, or if you square it, we'll get I square as minus 1. That means we can replace this I square by minus 1. After that, if you see, we are having this as a number, a real number, this as a real number, where these two terms are with I, that is imaginary parts. Now we can simplify it further, where 8 minus 6 into minus 1, that is, it becomes 6, then 8 plus 6, 14, right? And 12 plus 4, 12 minus 4, sorry, 12 minus 4, it is 18. Now, whatever, here what we understand is, whatever the expression they give, so we use a simple multiplication kind of thing, or addition, multiplication, whatever is given. Then we'll try to put it in the format. Now it is in the format of x plus ib kind of x plus ib, where x equal to 14, y equal to 8. That is real part equal to 14, complex part equal to 8. Right? So now suppose same problem if you take up this with 4 minus 2. So in the previous case, it is a multiplication where we multiplied and we simplified it and we had the form x plus 5. Whereas here plus is the right, we'll try to put it in the same format where real parts will take, we club together, that is 2 plus 4, these two are real numbers, plus then imaginary part. Imaginary means the terms with I, 3i and 2i minus 2i. So I, if we take out, then 3 minus 2. Now it becomes 2 plus 4, 6, 3 minus 2, 1. Okay. So here multiplication, we did multiplication and we had this, then we can answer this. Here in this case addition, then we completed the formalities, then we had a number that is expressed like that, right? Now we can answer this, real, what is the real part of this 6? What is imaginary part? So here only one I it is, therefore 1. So like this. So when this is a mostly what we can have, and a very simple thing, right? Similarly, if it is given, what is the absolute value of this? Suppose the same person given, what is the absolute value of the expression given 2 plus 3i into 4 minus 2i? Then we do the same thing, then we work on what is the requirement. So here, absolute value, we remember it as square of this plus square of this. Why it is simple answer here is, this is how I is defined, right? Actually, whereas mathematical like the validations are there, but the simple answer is, this is how it is defined, based on which the entire complex number discussions happen. Shreyas, I think. that is, some proofs are there, some validations are there. For us, simple understanding is I is something which is nothing but square root of -1. Yeah, that actually mathematically, if you go to advanced mathematics, there are validations for this. Now, as of now, what we can understand is something which is defined based on which the entire concept is. Yeah. It is like fixed value. You can 0 factorial equal to 1. Right? 0 factorial equal to 1. Like this, we can take as. Okay. No issue here. This basically this session is meant for such kinds of Q&As. Now here, I think once we understand the previous discussion, then we can answer any query of this. Now find the complex conjugate of this. Right? Same thing kind of, similar kind of. So we know complex, again I repeat, complex conjugate means suppose 2 plus 3i is there. Its complex conjugate is 2 minus 3i. Suppose 2 minus 3i is there. Its complex conjugate is 2 plus 3. Suppose minus 2 plus 3i is there. Only in between this way it varies, minus 3. Suppose minus 2 minus 3i is there. Then it becomes minus 2 plus 3i. These are all how we can say they are corresponding complex conjugates. That means to have the conjugate, what we need is we need the expression which is in the form of a plus ib or x plus ib. Now, so here also the same thing. What we here multiplication is given, right? So we need to do a simple multiplication. I think it's almost like a very basic multiplication. When we do that multiplication, wherever we see I square, we need to replace it by -1. After that, we have to group it. That is the terms with I, without I. Right? That is where we are getting this. Now, once we have this conjugate, now we clearly understand conjugate. We get just by replacing this what we call as plus by minus, we'll get the corresponding conjugate. Right. So now I think we understood conjugate and also absolute value. Right? Any queries? Any? These are the this is the basic concept based on which we can have many discussions. Now I'll take one more kind of example here. So previously we saw the addition multiplication, right? Now what happens if we go for what we call as a division, right? So earlier things what we have done, 2 plus 3i into 1 minus I. Then we did the product, then a plus ib, then real part, imaginary part, conjugate, absolute value, all those things we had. Similarly, other one is 2 plus 3i plus 1 minus I. Then also simple addition we do. Then we can have a real part, imaginary part, absolute value, whatever we need. So even in case of minus as well, this simple things, right? Now here the discussion is, suppose if it is a division, then what? Here also the basic idea is the same. That means we want this expression to be written as something like this. So how to do this, right? That is the discussion. Now in such cases, what we need to do is, here 1 minus I is there, right? That in denominator, whatever the complex number is there, what is its conjugate? what is this conjugate? Plus minus this is there, right? We'll get 1 plus I. So now we have to multiply by the conjugate. Then what happens is 2 plus 3i. Very simple actually. Into 1 plus I by 1 minus I into 1 plus I. I think we know why we are doing is to put it in the format. By here 1 plus I gets cancelled, we'll get the same. So without disturbing it, what we are doing is we are multiplying this by the complex conjugate of the denominator, not numerator. Then now I think we understood this is simple multiplication. That is, first we have to multiply it by 2, that is 2 plus 2i, plus 3i into 1, that is 3i, plus 3i into I, that is 3i square. Here also we can do the same thing, or this is simply if you recollect it, very good, we can use it. A plus b into a minus b equal to a square minus b square. Or if you can't remember it, just multiply it. We can multiply it, right? That we do here. Multiplying it by 1 plus I. Then with minus I and minus I square. Then we'll simplify numerator as well as denominator. Here we know this I square here is minus 1. Then what happens is here 2 is there, here minus 3 is there. So we'll group these two. Yes. Here this is with I, this is, that is, both are imaginary terms, we'll group them. 2 plus 3. Now in the denominator what happens? This is plus I minus I gets cancelled. This I square is minus 1. Already minus is there, therefore it becomes plus 1. Now if you simplify this 2 minus 3, that is minus 1. Plus 2 plus 3 is 5. 5i. By 1 minus of minus 1, that is plus 1. 1 plus 1 is 2. Now it becomes this. Now, I think maybe sometimes we may get the doubt like how to separate this. Very simple. We can separate this, right? Minus 1 by 2 plus 5 by 2 into I. Now, this is real part and this is imaginary part. I hope. So, simple. Addition, what to do. Multiplication, what to do. Division, what to do. So, in all the cases, we need to write the expression in a simplified form like this. In case of addition, simple addition we do. In case of multiplication, we do simple multiplication. And wherever I square is there, we replace it by minus 1. In case of division only, what to do is this denominator we have to take, and what is conjugate? Conjugate is replacing this join in the reverse. So the minus is there because plus. Then multiply it by the same. Then simplification. Once this is there, now we can play with it. Suppose we want conjugate is. Suppose if you want modulus of this, absolute value, modulus, any name if you want, you can use. Now it is nothing but real part is this minus 1 by 2. So squaring of it. 5 by 2 squaring of it. Okay. YC is correct. Okay. Now is it okay? Can you confirm? Like, is it?
Yes, sir. It's okay now.
Yeah. So, any queries on this? Like about now, we can understand complex numbers is a very simple thing. Right? There are some complex things, but on the whole, basics of complex numbers is as simple as that. And in this one more small concept is every complex number can be written in a form. That is what we call as a modulus, amplitude, something like this. So mod amp form, what we call as. Very simple. That means we'll convert this in another form, which is having very important applications in our subjects. That we are not getting into. So two things. One is R, other one is theta. So these two things what we want. So very simple. We know this is X and this is Y, right? So this is a real part X, this is imaginary part Y, where R equal to as simple as that is under root of X square plus Y square. That is 3 square plus 4 square. That is 25. That is 4. And this theta is how we get this tan theta is tan of Y by X. That is imaginary part by real part. Okay. This having some name, that is modulus, amplitude. We need not worry about form. So whenever it is in terms of numbers like this 3 plus 4i, we want to express this in terms of r and theta. How do you have r and theta is? R is square root of x square plus y square. Theta is tan inverse of y by x, imaginary part by real part. Okay, yeah. With this, I think now, I hope, now complex numbers is very simple topic. And maybe you may have a doubt. Suppose 3 numbers are there. Now, before going for the next topic, suppose if it is like 2 plus 3i plus 1 minus I plus 2 minus 7. Now, what is the real part of this? What is the imaginary part of this? Complex conjugate. Any question on this? Now, the same approach, whatever we did do in case of two expressions, two numbers, the same happens for the three numbers. Like all we have to group, right? 2 plus 1 plus 2, all without I. Next, with items, 3 minus 1 minus 1, right? Like this we do. Okay. Suppose if it is a multiplication, same way multiplying 3 numbers. Right? Next, very simple topic is quadratic equation. Right? Quadratic equations. That means the equations or expressions of this form ax square. So ax square plus bx plus c is something called as a quadratic equation, right? So here is a fixed one where we may have some numbers in place of otherwise. So always it should have x square and x square and constant. That is. So here in for this, what we need is solution. What we call as solution of this equation.
Y.V.K. sir, sorry to interrupt.
Solution means what? The number, if you replace x by a number, it should become 0. So that is called as a solution.
Sir, sorry to interrupt.
Yes, please.
Your voice is breaking.
Now I think clear, right? Shall I proceed?
Yes, sir, it's working now.
So this is what ax square plus bx plus c equal to 0 then. So now what is that we require for this is we need to find a value for x which satisfy, that is here if I put x as 2, right, then what happens, 2 square, that is 4 minus 5 into 2 plus 6. If I simplify here, 4 plus 6, 10, 10 minus 10, 0. That means x equal to 4 is called as a root or solution. Because it is a quadratic equation, it will have two values which satisfy this. Next idea is how to find it. One is by substitution. If options are given, we want to validate. Or otherwise, one is factorization. We need to factorize, find the factors, then from that we can find. But here, sometimes it becomes difficult for us to find the relevant factors, how to write like this. Helps us always to find the solution, where x equal to minus b plus or minus square root of b square minus 4ac by 2a. So now we need not worry about how to find the factors. Simply with the help of this expression, we can find the solution. Let us try with this. Suppose here this equation will take how to find solution or roots. Here minus b, here a equal to 1, b equal to minus 5, c equal to 6. That we use here. Minus b minus or minus 1 plus square minus 4, a is 1, c equal to 6. My 2 into a is like this. So whatever the expression is given, simply first we need to say what is a value, what is b value, what is c value. Just to plug in those values here. Right? Now what happens if we can say extend this minus 5 plus or minus square root of 5 square is minus 5 square, or 5 square, always square use the positive, right? 25 minus 4 into 6 fours are 24, right? 2 ones are. Now what we are getting is minus 5 plus or minus 1 by 2. What in this plus or minus is once we take plus, once we take minus, so that we'll get two roots. So that is what we do is minus 5 plus 1 by 2, minus 5 minus 1 by 2. Minus 5 plus 1 means, here I think you might have observed some typo. Minus of minus, it becomes plus, right? Plus. Minus of minus into minus plus. So 5 plus 1, 6 by 2, that is 3. Right? 5 minus 1, 4, 4 by 2 is 2. That means x equal to 2 comma 3. These are the roots, which are our regular roots, real roots, what we can call them as. Right? They are regular roots, real roots, what we call as. So here, so what are the points we need to have is, one is finding the roots in this manner. Second one is, without finding the roots, we should be able to tell what kind of roots it will have. What kind of roots means real roots or complex roots and so on. Right? So that means without substituting the values, we should be able to tell what kind of roots this equation results in or gives. So 1 minute. So that means here, suppose if we take suppose here something like 2x square minus 5x plus 1 equal to 0. Now we don't want, if we want to find the roots, then what we have to do is a equal to 2, right? B equal to minus 5, C equal to 1. then we use that expression, right? Minus b plus or minus square root b square minus 4ac by 2a. This we use. Now, without using that, we don't want the values. We want to find what kind of roots we'll get, whether real roots or imaginary, equal, and so on. So for that, what is important is this expression, whatever is there inside of this, that is b square minus 4ac. So now from this we can understand b square minus 4ac is positive, then we'll get some real, right? Positive square root of positive 4, 5 gives a number. Therefore, we get real numbers. Inside is positive, then real numbers. If b square, this becomes negative, just now we saw it, right? Under root negative, that becomes complex. If it becomes 0, then simply minus b by 2a will be there. That is what we use here. We will try to find what happens to b square minus 4ac. If it is positive, then real. If it is negative, complex. If it is 0, we can give the roots directly. So that is what we can say, nature of roots without solving. Nature of the solution or nature of roots without solving it. Now b square minus 4ac, b is minus 5 whole square. Minus 4a is 2, c is 1. 5 minus 5 means minus 5 into minus 5 becomes 5, 25. Now this is 4, 2s are 8 minus 7. 17 is greater than that means whatever is there under root is always positive, is what we get is real roots, right? How many roots? 2 roots. One is with plus, another one is with minus. Suppose it becomes negative, then what we say is complex roots. Suppose this becomes 0, then what happens? This part becomes 0, then we get same root, minus equal roots or same roots we get same. And the roots also nothing but minus b by 2. 2 times we get the same. Like if we take x square minus 2x plus 1 equal to 0. So this is nothing but x minus 1 whole square equal to, that means x equal to 1 comes twice. We can verify. So if you take this example, if you find b square minus 4ac, what happens? B is minus 2, so minus 2 whole square. Minus 4a is 1, c is also 1. 4 minus 2 whole square is 4, 4 minus 4 equal to 0. That means this part becomes 0, that means we have same root, minus b by 2. So this is another one simple understanding. So any doubts or any queries on theory of equations? Sorry. Almost most of the things similar to this explained in the video. Yeah. Thank you. Yeah, for that you can see find roots of the equation or real, complex, something like this. They want to have it. So very simple, right? Only that if you recollect minus b plus or minus n. So they are not asking for the numbers, what kind of roots we get. Then a equal to 2, b equal to 3, c equal to 1, b square minus 4ac greater than 0. Therefore, the roots are real and different roots. One is with plus, another with by taking minus. This is one. Now the opposite one. Opposite is if the roots are given, finding the equation. Right? Now till now, what we try to understand, if this is given x square minus 3x plus 2 equal to 0 is given, how to find the roots? Here roots are, if you solve it, and not solving, I just have 1, 2 by using any method. Now, if only this is given, x equal to 1, 2 are the roots, then what is the equation corresponding? What is the corresponding quadratic equation is requirement? So, how to find this? How to find this is, now if you closely observe here, 1 plus 2, 3 is there. 1 into 2, 2 is there. 1 plus 2, 3, but minus 3 is there. 1 into 2, 2 is there. So from this, what we can understand this one. X square is fixed minus sum of the roots into x plus product of the roots. Right? Suppose 2 comma minus 3 are the roots. What is the equation? Right? Now, what is the sum of this? Sum of these roots, 2 minus 3, that is minus 1. Right? What is the product of these two? 2 into minus 3, that is minus 6. Then equation is x square minus some, whatever sum is there, that is minus 1 here into x, plus product, that is minus 6. That is x square plus x minus 6 equal to 0. This is one aspect of this. So first one is, if the equation is given, finding the roots, and also without finding the roots, comment on the roots, real, complex, equal, imaginary, and so on. The second aspect is, if the roots are given, then reconstructing the equation from it, for which we use this, where we take sum of the roots here and product of the roots here. So other one is, if you take this ax square plus bx plus c equal to 0, suppose it is some one relation is, if the roots are alpha comma beta, then sum of the roots is minus b by a. So minus b by a. And product of the roots is the constant by. So this is one understanding. Let me see. Any queries? Any queries? As far as the two topics what we reviewed, that is any queries related to anything that you are not able to know. Yeah, thank you. So next, this is too much simple actually, comparing with the previous two things. This is what we studied in our school. That's why the requirement is very simple math, what we studied in school itself, the two in 8, 9 standard, something like that, preschool kind of thing. So one is the arrangement of numbers, okay? Something related to arrangement of numbers. Many ways are there. So two things. One is very simple. Suppose if you see these numbers, and similarly, that's it. Now we can observe two kinds of patterns here, two different patterns here. What is that? What is your observation? What is the observation here in these two patterns of numbers arranged? First one is addition, second one is multiplication of same number, right? Suppose if you see here, 3 plus 2, 5, 5 plus 2, 7, 7 plus 2, 9, 9 plus 2, 11, right? So that is here 3 into 2, 6 into 2, 12 into 2, right? This is what we are. So, but there is some name associated. First one is called as arithmetic progression or AP. This is called as AP or arithmetic progression. Now, if you say the multiplication, right, 3 into 2, 6 into 2, 12 into 2, that is another pattern which is geometric progression. Popularly we call as GP. Right? The other one, harmonic, is not a new thing. It is a reciprocal of AP. Reciprocal of AP, 1 by 3, 1 by 5, 1 by 7, 1 by 9, 1 by 11 if you take, right? So that is what is called as harmonic progression, right? So otherwise we understand AP and GP. Right? So now what are the things that we need in this case? 1 minute, any queries? Sure, Fraji. I think our team, the team takes care of that because they will have all the numbers, mail IDs. So now, so what are the things that is required? Very, very, very simple here. Very simple in sense. Now, if we write like this, keep on doing like this. I want what is the 28th term? Right? What is the 28th term or 100th term? Without writing it, without keep on writing. All of a sudden we want what is 28th term. So that is where we try to observe a pattern. We write nth term of this. If you see here, if you see this clearly, here 3 plus 2, right? That is a plus t. Now 7 we are getting by adding plus 2. That means nothing but 3 plus 2 plus 2, right? That means a. This is called as a. Actually, first term is called as a. If we add, d is called as common difference. So 3 plus 2, 5. We are getting second term. Right? When we want third term, what is happening? A plus 2d we have to write. 2 into 2, 4, 3 plus 2, 7. That means if first term is a, second term is a plus 2 minus 1. Third term is a plus 3 minus 1, like this. Therefore, nth term is n minus 1. Very simple. Now, suppose we want 8th term. Then simply a plus 7d. Right? A is how much? 3 here. 7, d is that constant which is added, right? That is 2 here. Therefore, 3 plus 7 2s are 14. 14 plus 3, 17, like this. Right? Now, in the same way, see any queries. Same way, the multiplication part, that is GP, what we call as, right? So, 1 minute, any doubts before proceeding? Talal, I think my team will answer this. How much percentage do we need to in order to pass qualifier? Can we use the calculator or copy for a rough work? I think our team will answer. So when we talk about multiplication, it is, if you see here, 3 into 2, right? Next, when we go further, it is 3 into 2 square. It we are multiplying it for that, right? That's why if you see here, 3. Right? Next is 3 into 2. Next is 3 into 2 into 2. That is 2 square. Like this, we are getting, right? This is the first term. This is second term. This is third term. This is fourth term. There, if you see the observe here, second term power is 1, next power is 2, power is 3, therefore a into r power n minus 1, where a is the first term, r is the common factor which we are using and which we are using for multiplication. Right? That is. Okay. Now, same if you take, now we want 18th term here. So a is here first term, which is 3, right? And r is 2, right? 18th term we want, right? 18 minus 1. Okay. Now it is 3 into 2 power 18 minus 7, 17. Right? No need to multiply it. If it is a simple number, we can multiply it. Otherwise, we can ignore it. Okay. Then one more is sum of n terms. Right? Sum of n terms. Right? I think this maybe we might have played in the school. Now 1 plus 2 plus 3 so on up to 100. Without calculating, you should be able to tell what is the total in a minute. That is where we talk about sum of n terms. That is sum of 10 terms, 20 terms, 30 terms, 40 terms, like this, where it is n by 2 into 2a plus n minus 1 d. Or if you know the first term and last term, then n by 2 into first term plus last term. Sum of n terms. Suppose this is a famous example, 1 plus 2 plus so on. We need not add it. Without adding, we should be able to tell what is the total. So how many numbers are there? Total 10. N is 10. 10 by 2. First term we know in this case, that is 1. Second and last term we know, that is 10. Then it is 55. So similarly, if you take up to 100 terms, right? N equal to 100, because it is 100 terms, sum of 100 terms, right? Therefore 100 by 2. So first term 1 and last term is 100, right? So 100 by 2 is 50 and sum of these two is 101. So this we can use only when we know what is the first term and what is the last term, how many terms are there. Right? If not in the sense, like 1, 3, 5, 7, 9 and so on, find sum of first 48 terms. So we are not going to write all 48 terms and use this, no, right? In that case, simply we can use n by 2, that is 48 by 2. 2 into a means first term, that is 1, plus n minus 1, 48 is n, right? 48 minus 1. Into d, what is that constant term we added? That is 2, right? 2, 1 plus 2 plus 3, 3 plus 2, like that is d, right? So this gives the sum of n terms. And that too, I hope I need not mention it, which series it is, arithmetic progression, because the addition related discussion we are doing. In a given AP, we can have sum of n terms by using this expression or by using this expression, depending on the information available. If first term and last term is available, then we can use, otherwise we can use this. Any doubts on this? Similarly, for GP also, I think the formula is the difference. Otherwise, it is the same discussion. A into r power n minus 1 into r minus 1. A into r power n minus 1 by r minus 1. Same, A is first term, r is the common multiplier, the factor, right? That is, n is how many terms? Here, two things are there. One is depending on less than 1, greater than 1, two formulas. 1 minus r or n into by 1 minus r. How to find a and okay, I'll tell you. A and D in the sum of n terms. So A is first term, right? Yeah, that is a good question actually. I should have explained it. A is whatever the first term is, that is A. I think that is very easy. Well, how to get D is just subtract any consecutive numbers. So 5 minus 3 or 9 minus consecutive earlier term by previous term. Right? 7 minus 90. Right? That is D. Okay? Suppose I take something 28, 31, 34 like this, suppose. What is A here? A is the first term, which is 28. What is D here? If you want to take any combination, suppose take this 34 minus 31, that is 3, that is D. Okay, like this we can find A and D. Not only this, even at the beginning also, if you want to find nth term of this AP, then also we need A and D, right? This is how we can find A and D. Okay, I hope it's clear. Clear, right? Yeah. Okay, good. Thank you. I think I should have explained it. Clear, right? Yeah, okay. So, okay, right. Okay, let us proceed further. Something which generally we feel difficult kind of thing, I assume, but very simple actually. Let us see how simple it is. How many, just how many of still carrying that impression trigonometry means that is so complicated? Still carries the same fear, like trigonometry, which is complicated. So very simple. First, the basic understanding is required. Basic, that is a right angle triangle, or that is what first requirement is, right angle triangle. Then in right angle triangle, we have the two things, right? One is so sine. So where this is the right angle. Right? If you take this as theta, then this becomes opposite side. This becomes the adjacent side, and this is all anyhow hypotenuse, right? Suppose if you take here as theta, then this becomes opposite, this becomes adjacent, then hypotenuse remains the same. Right? So once it is clear, then finding sine theta. Sine theta is so opposite by hypotenuse. Right? Sine theta, if you take sine theta, is opposite by hypotenuse. Similarly, cos theta, adjacent by hypotenuse, that is 4 by 5. Tan theta, opposite by adjacent, 3 by 4. And for all these things, we'll have a reciprocals, right? Sine theta, if you take reverse of it, 1 by sine theta, it becomes cosecant theta. So reverse of 1 by cos theta becomes secant theta. Tan theta, if you take corresponding pair, is cot theta. Right? So the entire trigonometry discussions mostly follows in and around these discussions. So how to find sine theta, how to understand cos theta, then relation between sine and cosine, sine and cosecant, secant, and tan, as well as cot theta. So once how to find it is, suppose sine is given, how to find cos theta. Right? Sine is given, how to find cos theta. Or if sine is given, how to find the remaining values or expression and so on. Let me take one instance. Now we don't, I think we'll close our eyes and say sine, this is given. Sine theta equal to 3 by 5 is given. And we need to find all the remaining values. Only sine theta is, then immediately we'll draw this. And sine theta is opposite by hypotenuse. Therefore, this is 3 and this is 5. Then this is not given. Then we have to find this, where we use this Pythagoras, right? Where in Pythagoras we know sum of squares of these sides equal to hypotenuse. That is AB square plus BC square. These two are sides. This is hypotenuse, right? Where this is given, this is not given. Therefore, we can find this. That means, so first we need to understand what is given. Sine theta is given. Then we should know what is the expression for sine theta, opposite by hypotenuse, right? So based on that, we'll find the remaining. So we get here, we got it 3 here, 5 here. We have to use Pythagoras leftover unknown, leftover the side here. So once these 3 we are having, we can play with anything that they want. Suppose cos theta, we know cos theta is adjacent by hypotenuse, that is 4 by 5. Tan theta, opposite by adjacent, 3 by 4. Reverse of reciprocal of tan theta, cot theta, which is not only this, any multiplication. Suppose sine theta into cos theta is how much? Something like this. Sine is how much? 3 by 5. Cos theta is 4 by 5. 3 into 4, 12 by 25. So like this. So first understanding is what is the expression and how to relate this with the right angle triangle. Right? Then try to complete the right angle triangle with the numbers by using Pythagoras relation. Right? Once the right angle triangle with all the values with the sides and hypotenuse, then we can find remaining trigonometric ratios, multiplication, addition, anything that we require, we can do it. Right? So this is next one more extension. This is, we know about this quadratic expression, Cartesian system, what we call, right? So where it is the first quadrant, this is what we call a second quadrant, this is third quadrant, this is fourth quadrant. And the angles also in 0, 90 degrees, 180 degrees, and 360 degrees. So what happens is, if the theta is from 0 to 90, all values are positives. All trigonometric values are positives. Sine, cosine, anything. So anything is here positive, right? If sine, cosine, any trigonometric value. Whereas between 90 to 80, only sine is positive. Remaining all are negatives. Similarly, 182 to 360, only tan is positive. Similarly, 360 to 270 it is, it is 360. 270 to 360 means fourth quadrant, where only cos is positive. Cos means immediately it's sec also. Tan means immediately cot. Sine means immediately cosecant. Okay, like this. Now let us try to understand this example with this concept. Right? Here, sine theta equal to minus 3 by 4. And here clearly given, that's why there is no problem for us. Theta lies in the third quadrant. Okay. Sine theta is negative. Right? Sine theta is negative. So where sine is negative, sign becomes negative either here or here. Here sign is positive, here also sign is positive. But here mentioned clearly third quadrant. So that means the discussion whatever we are having now is in this. This is the area. This in this quadrant we are having the entire problem and discussion. So first we need to identify. So once it is done, remaining things are very simple. So already we are having from the previous one, right? Whenever sign is negative and immediately cosecant becomes negative. Then cos theta, previous I think I am not repeating it. When sin theta is 3 by 5, then right angle triangle we can have cos theta as 4 by 5. Okay? Then tan theta also we can have it as 3 by 4. So here how we are getting these numbers, like what we discussed previously. Now here the point of discussion is cos theta equal to 4 by 5 actually, because it is lying in this place. In this place cos is negative, right? Only tan is positive. Therefore minus 4 by 5. Cos square, therefore the same. Tan theta is 3 by 4, but the discussion is happening in this quadrant where tan is always positive, therefore 3 by 4 is positive. Okay. So I repeat, how to differentiate is, if anything like this is not given, just sin theta value is given, the previous approach we go for. If something like this is given, right, using the previous approach, we have to find all the relevant values here, cosecant, cos theta, tan theta. Then next we have to see what is the place or the quadrant in which the discussion is happening. Here it is clearly mentioned third quadrant, that means this. Then immediately here how we remove this, generally all students takes coffee. This is how we remember. All students takes coffee. So this third quadrant means take means tan and cot. The only here tan and cot theta are positive. Remaining all are negative. That's why cosecant negative, cos negative, tan positive as well. So any doubt here? Let me see. So, this is about done. Some I think there's regular expressions like that. And one more, I think this is another important aspect. There are two like kinds of expressing the angles. Actually, one is radians, other one is degrees. Right? There is a relation. We are not getting into what is radian and degrees. There is a relation between these two. Pi radians equal to 180 degrees. Now, particularly with respect to exam, conversion, radians is given converting it into degrees. Degrees given converting into radians. So very simple. Now, if you see this, 9 pi by 12 is given in terms of radians. Now, what is its equal representation in terms of degree? Very simple in this case. So we know pi. We have pi is nothing but 180 degrees. Pi equal to 180 degrees. Simply replace pi by 180. So pi by 180, then simplify it. Right? That is where now the 135 is degrees, corresponding expression in degrees. Right? 135 degrees. Similarly, 270 degrees. Here reverse. 270 degrees we need to express in terms of pi by 8. How to have it now? This is where then 1 degree equal to pi by 180. So this is. So 180 degrees, 180 degrees equal to pi radians, 1 degree equal to pi by 180 radians. So therefore now you can see here pi by 180 into 270. Simplification gives 3 pi. You can verify this 3 by whether this conversion is correct or not. Pi is 180, 290 is 90 into 270. So like this we can verify. This is one other, I think maybe you can say very useful information, important. That is converting radians into degrees, degrees into radians. For which what is required? The equation pi radians equal to 180 degrees is required. If you are having any doubt, you can practice one or two. Take just randomly take convert it, and we can verify also. Right? We can verify also. These are something. Set theory is it is another easiest of the easy things, particularly finding A union B, A intersection B, and so on. Right? I hope this is a very simple concept, finding union intersection. So two sets A and B are given. Okay. So operations, one is joining, very simple. Union means joining. Join the two. That means combine both. Put all the. So this is one basket. This is another basket. If you are going for union means reunion, we say, right? School reunion, right? So put all those things in a basket. If anything is repeated, put it only for once. That is the simple thing. So here we can see this. Join A union B is nothing but put two baskets. All the this is one basket. This is another basket. Union means put all those things in one basket. If anything is repeated, remove it. Keep it only. That is intersection is a crossroads. Right? So where what are the things which are common to both? So here 5 and 6 are there. Here also 5 and 6 are there. That is intersection. Now same applies even suppose if you say A union B union C. Right? A intersection B intersection C. The same holds good. Here A is one basket, B is another basket, C is another basket. Union means put all the three into one basket. Wherever repetition is there, make it as unique. Intersection of three. Right? Of all the three baskets, what are the common things? You take it out. That is A intersection, B intersection, C. For example, suppose 1, 2, 3, 4. This is 1. 2, 3, 5, 6 is second one. Right? Third one is 3. 2, 3, 7, 8 is the third. Now intersection of these three. So two elements are there in the all the three. Is the so I think set theory is something which you can enjoy most of the times. This is the basic, but the maybe number of baskets increases accordingly. We have to do the same. Next, other one is relations. This is also a very simple topic, very simple known topic is. But only thing here is writing it in the different forms. One is in terms of matrix, another one is in terms of the diagram or called as a graph. This is called as a graph. So this is called as a graph. and this is called as a matrix. So set is given and the relation is given. So how to put the matrix is very simple. Very simple. Here 1, 2, 3, 4, right? 1, 2, 3, 4. Means what we are writing here is what are the combinations that are exist, what are the combinations that are not there. So if any combination here, if I say this is 1 comma 1, whether this combination is there, yes, we'll put 4. Now if we go this 1 comma 3, this combination is not there in the given relation, therefore it is 0. Like this we can put it in the matrix form. Okay. Similar to that, there is like Rangoli where 1, 2, 3, 4, wherever entry is there, there exists a relation 1 comma 1, 1 comma 1, 1 comma 2 comma 2, 3 comma 3, 4 comma 1 to 2. So there is an arrow from 1 to 2. 3 to 2. 3 to. So 2 comma 3. That means opposite 2 comma 3. Like this we can write. For a given relation, we can have matrix as well as we can have its graph representation. And vice versa also. Vice versa in the sense, suppose this matrix is given, what is the relation? This is given, then what is the corresponding relation? Very simple. So wherever 1 is there, that comes in the relation. Wherever 0 is there, we need not consider this. Ignore these things. So 1, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 2, 3 comma 3. So that is one based on this. These 3 terms are, yeah, please. Yeah, please. Yes, yes, please. You can ask the question. Yes, yes, yes.
Hello,
Yes, yes.
how are you?
Yeah, you have any doubt? Okay, I think by mistake it's answer. So here something called as a reflexive, symmetric, transitive, equivalence, and so on. If you understood whatever is explained in the video, it's fine. Otherwise, don't make the things complicated. Any doubt?
What
Yes,
are you
yes, you can
doing?
ask the question, but we are not able to hear you. Bilahi Jana.
I ask you,
Yeah, you ask any doubt that your hangar post.
what I study this course.
Can you type it? Maybe I'm not able to understand. I hear you properly. Can you just type it?
This program is free for a poverty family.
This program is. You can type it. I think you can just type it in the chat. So if it is relevant, I'll answer. Otherwise, our team will answer. I think that is best. Okay. So the next is relations, right? This is, I think, sometimes it is confusing concept. Differential equations. So here, just like our regular equations, right? X square plus 2x, right? That we know, right? So there it's very easy for us to define it. So if you take this, we know x square plus 2x plus 1 equal to 0. This is quadratic equation, right? That is why we call this as a quadratic equation. The highest power is 2x square. Right? Now, similar to that, in place of this, derivatives are there, dy by dx. Now, this is that called as a derivative. This is called as a derivative. Right? But what is the difference here? This is the first derivative. This is second derivative. Like this. Now, so that is what we call them as differential equation. So here in this case, very simple to say this is order 2, order 3, where we are having some names. Similar to that, when we take differential equations, that is in equations involving derivative, we use two terms called as order and degree. Okay? So what is this? This is a very important thing for us. Now we understand this is y and it's dy by dx first derivative. It's second derivative, d square by dx square. That means we understand what is the highest derivative, second derivative is the highest. So therefore order equal to 2. Okay. Suppose, for example, it is d cube y by dx cube plus something like this. Then this is second derivative, this is third derivative. So then we say order equal to 3. That means in a given equation, what is the highest derivative with the first derivative, second derivative, third derivative? Therefore, order is 3. Right? Now, similarly, if you say this, what is the order here? Y, the first derivative, it's a second derivative. That is where it is stopped. Therefore, order equal to 2. Okay. So here also y dy by dx, d square y by dx square, that is second derivative. Therefore, order equal to 2. Right? The first term is order. So next is degree. Degree means, so whatever the highest derivative we are having, right? What is the power of this? Power means this 2 is not the power. This indicates the second derivative. Right? So what is the power for this? There is no power. That means power 1. Therefore, degree. This is the highest. This is a caution here. We have to be cautious here because here directly what we say is second derivative. Therefore, order is 2. Its power is 1 by degree is 1. No, not wrong. Why this is wrong? There is a condition. While doing so, we have to make sure that there is nothing like this. Power 1 by 2, power 1 by 3, square roots, all should not be there. We have to remove them. How to remove them? Here in this case, square it. We can square it. If you square it, it goes, right? Then d square y by dx whole square, dy by dx plus 1 to 1 by 3 at the end. Right? Now, this is the highest derivative whose power is 2, therefore degree. In between, I think it got disconnected, it seems. So this is, I think, maybe you can spend some time and have a refresh. You can refresh this. Okay. So whether it is free from all those things, if it is so, then we write order and degree. If not, we have to make it without these 1 by 2, 1 by 3. I think I touched some of the confusing topics here. There are many. So any doubt? I think I stop my lecture here, my discussion here. Feel free to ask any doubts. Like some of the things you may not feel comfortable. Leave it, and focus on the things which you are comfortable. Revise those topics. Right? So, for example, if you take applications or derivatives, you may not feel comfortable. Just you can ignore and proceed further with the remaining topics. Okay, I think this is from my side. I think I revised some of the confusing topics. Yeah, this will be shared. And one more thing is, don't feel like a very difficult. If you see that games, if you are following any of the games, what the batsman do, any greatest batsman in the cricket or any game, so they leave the difficult balls, right? You capitalize the balls which they can play, right? Particularly, I watch cricket, that's why I'm giving, right? You take any greatest player, he can't play all the balls, right? That's why what I mean is, if something which is I feel very difficult, leave it and focus on the things which are good and accommodative for you. Okay? Because at the end of the day, no one can answer all the questions given. No one, right? No batsman can play all kinds of balls without any difficulty. That is highly impossible. Right? So don't worry about. Be confident and attempt the questions. Right? Thank you.
Thank you, sir.
Yeah, I think we can. I think this PPT will be shared. I think don't worry. Right? Yeah, thank you. Thank you guys. Good luck, and let us meet another part of the program after completing the admission formalities. Okay? Don't worry about complex mathematics. Right? Okay, thank you.